Welcome. Today we're going to be looking at the potential divider using two variable resistors wired in series. Though more conventionally, you may see this with two fixed value resistors. Our power supply will be a sine wave generator. This is just because it's more interesting to observe than a plain DC flat line. And it won't make any difference in this circuit as it's purely resistive. Whereas if we had an inductor or a capacitor in there, then obviously the results would change because of the AC. We're going to probe V in, shown on the trace as a yellow trace, and V out shown as a blue trace. Like every video I make, before jumping into formulas, let's first build some intuition by observation and work out some approximate equivalent circuits to start building some understanding. First of all, we can see that we've picked the same value resistor, in this case around 5k, and we're getting about half V in at V out. One thing to bear in mind is the potential dividers is that V out will always be smaller than V in, else you'd have a negative resistance, which actually is not as silly as it sounds, but will stick to positive resistances. If we now lower R1, V out slowly creeps towards V in. We could create an equivalent circuit that shows this as a short to V in at extremely low resistances. If we had an extremely large resistor, say we swapped 5k to 10 mega ohm or something, then this would have an equivalent to an open circuit that does equal ground. Now let's consider R2. If we lower the resistance of R2, we can see that V out slowly creeps towards ground. If we go the opposite way and we made R2 extremely large, say again 10 mega ohms, now we'll see it as equivalent circuit to an open circuit. So V out approximately equals V in. Let's just have a look at our equivalent circuits to recap. If R1 has a high resistance, then it acts more like an open circuit. But if it has a low value, then it will act more like a short circuit. So either make V out closer to ground or closer to V in. If R2 has a high resistor value, it acts more like an open circuit. And if it has a low resistor value, it acts more like a short circuit. This will either make V out either closer to V in or closer to ground. This demonstrates the relationship between R1 and R2. If R1 is larger than R2, then V out would be less than half of V in, i.e. closer to ground. Whereas if R2 is larger than R1, V out would be more than half of V in, i.e. closer to V in. If R1 and R2 are equal, then V out will be half of V in. Now we have a very basic feel for the circuit. Let's have a test. Using your intuition we have just built, will V out at this circuit be more or less than half of V in? Use the poll to record your answer. Now we have made some observations, let's introduce a formula for calculating V out more precisely. To do that, we simply use V out equals V in times R2 over R total. Using our previous question circuit, we can calculate V out to be 0.75 volts, so less than half V in. Did you get it correct? Finally, you may ask, what application would you use a potential divider in? Well, they're commonplace in sensor circuits, which might feed into a comparator or ADC. They can be used for signal level shifting if you have a 5 volt signal, but the chipset maybe you're using only is 3.3 volt tolerant. Bias enacting devices such as amplifiers. They also create a fixed voltage reference. One thing to bear in mind, however, is that they rely on a small stable current draw to prevent varying voltage output. So a potential divider will be a very poor choice for a power supply regulator or anything that wildly varies its current draw. That concludes our very basic analysis of potential dividers. In a future video, we'll look at using them with sensors, such as an LDR, but until then I recommend you build one of your own values and take your own measurements. For a DC supply, you only need a general purpose multimeter, so there's no excuse. I hope you found that helpful. If so, please give it a thumbs up, and until next time, keep experimenting.